Hello, Assalamualaikum and a very good day. My name is Nurhafizuddin bin Baharudin. I am from KK17 and our integrated project is production of Doxorubicin from Streptomyces Peucetius. My member is Nurul, Fatin, Najiha, Muhammad Azham, Aishah, Farina and Nadya, Pratiwi. Next is introduction. Doxorubicin is also known as Azham. It is an anti-tumor that used for medication in chemotherapy. So as we can see, there is figure for chemical structure in for doxorubicin. I'm sorry, and then there is table for physical and chemical properties. What I want to say is, our appearance for a product doxorubicin is in a solid phase. And lastly, a little bit of doxorubicin. Doxorubicin is used to treat cancer, such as stomach cancer, breast cancer, and bladder cancer.
Next is supply and demand. This is show supply and demand graph from 2015 until 2025. Next, list of companies. Table 2.1 show the list of companies with the capacity. And Johnson & Johnson were the first company in market that introduced doxorubicin formulation in 2012. The US FDA approved the importance of drugs and manufactured by Sun Pharma Global. A year later, it was approved as the first generic version of Doxil distributed and marketed by Sun Pharmaceutical. And the global distribution market was valued at USD 809.6 million in 2015 and is expected to grow at a compound annual growth rate of 6.4% over the forecast period. Next, for plant capacity, the demand is 547.22 kiloton a year, and for supply 515.3 kiloton a year, and difference between demand and supplies is 31.92 kiloton a year, and production time a year is 8,400 hours, and for the plant capacity 319,200 kilogram a year, and for product flow rate is 38 kilogram per hour.
For PFD, we got seed fermenter, main fermenter, decanter, absorber, distillation column and dryer. And we got stream 1 is glucose, stream 2 is ammonia gas, stream 3 is air, we got ammonium sulfate, we got bacteria which is Streptomyces. And then the first thing, the input will go to the seed fermenter, and then they will go to the main fermenter. And then the product will go to the decanter. Why we use decanter? Because we want to separate biomass. And then we go to absorber. Why we use absorber? Because we want to separate waste gas. Okay, because absorber is separate liquid and gas. So and then we go to distillation column. We go to distillation column. We want to separate wastewater because we don't want the byproduct which is wastewater. We just want our product which is doxorubicin. And the last one is the product will go to the dryer. Before the product will go to the dryer, the phase is liquid. So we use dryer to make it a solid. So our product which is doxorubicin is a solid form. Thank you.
For the mass balance, first we must find the stoichiometry for the equation by using Gauss elimination method. After that, we calculate the mass balance by using the equation mass flow rate inlet equal to mass flow rate outlet. For example, this is our main fermenter, and after we calculate, we get the balance value. For energy balance, first we must find the information before we calculate the energy balance. For example, the information are coefficient value for heat capacity of the component, standard heat of formation of each compound, rate of reaction and standard heat reaction of each reaction. After that, we calculate using this equation, and then the energy balance that we get is 845.9034 kJ per hour. Since the sign of this value is positive, So it is an endothermic reaction.
Next, there are properties of raw materials. There are hydrochloric acid. Risks and hazards, there are the eyes, skin, and mucous membranes are all harmed by this. Then for sodium chloride, this may cause inflammation to the eyes, ears, and respiratory tract. And for lactose, this is slightly hazardous of skin contact, may can cause irritant. And for methylparaben, this may can cause skin contact too, and can cause irritant and also absorption. And for doxorubicin hydrochloride, this material may be irritating to the mucous membranes. And for handling method, there are hydrochloric acid. It is only suitable for use in well-ventilated areas. And for sodium chloride, we must use with proper ventilation. And for lactose, we must stay away from sources of heat. And for methylparaben, we must keep away from direct heat. And last, for doxorubicin hydrochloride, we must not inhale gas, as well as exposing ourselves first to them. And for storage method for each component, for hydrochloric acid, we must keep it cold and dry. And for sodium chloride, we must keep it cold and dry too. And for lactose, we must store the container securely closed. For methylparaben, we must hold the container tightly closed too. And for doxorubicin hydrochloride, we must keep container tightly closed and store in accordance. And each generation in production of doxorubicin, there are biomass, is highly concentrated with living or dead cell. Next, wastewater is formed in the reaction of aerobic metabolism of the cell. Next is carbon dioxide is formed due to respiration cell. And next, there are waste treatment. There are waste gas is removed using by biofilter. And for wastewater, can contain minor impurities generated during processing. And for biomass and broth make up the majority of the biological waste generated. And next, there are main enzymes used in production of doxorubicin is cytochrome P450. These enzymes are found mostly in liver cell. However, they can also be found in other tissues. Next is metabolic pathway. For this enzyme, catalyze the reductive deglycosylation of doxorubicin to a 7-deoxyglycone metabolite, which aids in its detoxification. And last, for enhancement of doxorubicin production, the structural sugar biosynthesis chain DAS3 and DAS4 from Streptomyces venezuelae, as well as the glycosyl transferase PRD and RS and DIR and RQ from Streptomyces Peucetius were cloned into the expression factor PIBR25, which contain a strong RMA promoter.
Next is utility and pressure vessel design. For utility design, have two, is design of condenser and design of reboiler. And this table shows the physical properties for shell and tube that calculate from design condenser. And the summary of design of condenser, this is for tube side and shell side. Next, for pressure vessel design, in our plan design have two type of pressure vessel design. First is main fermenter and second is absorber. For the main fermenter, stainless steel grade 316 is using and as the material for fermenter. And table 7.2 shows the dimensions of main fermenter that have three parts of top, head, vessel, shell, and bottom head. And in our design, the MAWP of the vessel is 14.5 psi, and since the design criteria is follow, the thickness of skirt is 0.396 mm is acceptable, and considering the correction alone of 2 mm, the final thickness of the skirt is 2.588 mm.
Okay, for the separation part, we choose decanter for separate biomass and the other component. So, our parameter for decanter is for temperature is 35 degrees Celsius, pressure is 1.2 bar, volumetric flow rate is 3.843 times 10 to the power of -5, and for the speed is 14,722 rpm. For the ball, radius is 0.6792 cm and height is 45 cm. So for our process flow diagram, we've got two fermenter, which is the first one is seed fermenter and the second one is main fermenter. And then we got decanter for separate biomass. And then we got absorber. Absorber is for we separate waste gas. And then we got distillation column, which is we want to separate wastewater. Okay. And then the product will go to dryer. And then the final is we got doxorubicin in a solid form. So our input is glucose, ammonia gas, air, ammonium sulfate, biomass, which is Streptomyces. Okay, and then the first one is we the glucose, ammonium sulfate, Streptomyces, which is biomass, and air will enter to seed fermenter. It's for to strong the biomass, and then the biomass go to the main fermenter, and then the product will go to decanter. At decanter, we want to separate the biomass, which is
As conclusion, doxorubicin is an anti-tumor medication used in chemotherapy to treat a variety of cancer. The CAGR that we get is 6.4% from the global market. Our plant capacity is 38 kg per hour, as it already fulfilled 1% of global demand. The oxidation process absorbed at 845.9034 kJ per hour. Our main enzyme in this production of doxorubicin is cytochrome P450. For the separation process, we choose decanter as our unit operation, and the ball radius that we get is 0.679 cm and the ball height is 45 cm. For the pressure vessel, we also get the dimension for the fermenter and absorber. Thank you.